Hi everyone, this video lesson deals with the problem to find subtraction and addition formula for inverse trigonometric function. We start considering the first equality: arcsine of x plus arcsine of y equals arcsine of sine of arcsine of x plus arcsine of y. Using the addition formulas for sine function, we get arcsine x plus arcsine of y equals arcsine x times square root of 1 minus y square plus y times square root of 1 minus x square. Actually, this equality is valid only in first approximation. We should take into account the quarters of the unit circle, where arcsine of x plus arcsine of y is. So, this equation is a triple equation, and the third kind of equation are called y, double y, and triple I. Sorry, not y, I. Okay. We set arcsine of x equals alpha, arcsine of y equals beta, and x equal sine alpha and y equal sine beta in consequence of the previous relationship. Okay, we have alpha and beta belonging to the same interval, closed interval between 1/2 minus 1/2 of pi, 1/2 of pi. However, we are interested in the formulas related to the x and y, so we should to modify the three equations. Let's go. We first consider the double I equation. We have 1/2 of pi less than alpha plus beta, not greater than pi. Of course, we have x and y positive, and alpha and beta belong to the same left semi-open interval between 0 and 1/2 of pi. This inequation can be modified into pi Greek minus beta less than alpha, not greater than pi minus beta, and it becomes the one equation, one expression relation divided in two parts. The first part is pi 1/2 of pi minus beta less than alpha, not greater than 1/2 of pi, or 1/2 of pi less than alpha, not greater than pi minus beta. We have interested in the first part of 1, so because of increasing ratio of sine, we have sine of 1/2 of pi minus beta less than sine alpha, namely cos beta less than sine alpha, and squaring both the sides of the relation, the previous relation, this relation, we have cos square beta minus sin square alpha. So by the first relation of goniometry or trigonometry, we have 1 minus sin square beta minus sin square alpha, then sine square alpha plus sine square beta greatest greater than 1, so it becomes x squared plus x squared greater than 1. The second part of the 1 gives sine alpha not less than sine beta. Id est x not greater than y. This relation isn't important for us because of the symmetry of the variable x and y. Okay, if we change the first relation in terms of beta, we will have x minus not greater than y. So the second relation isn't important. The same thing will happen in the following reasoning in our video lesson. Okay, the double I relation. We have arcsin of x plus arcsin of y equal pi minus arcsin of x times square root of 1 minus y square plus y times square root of 1 minus x square, where 0 less than x y not greater than y, and x square plus y square is greater than 1. Okay, we have rewritten the double I in terms of x and y as it is suitable for calculating the correct expression. Okay, we are examining the triple I relation. We have minus pi not greater than alpha plus beta less than minus 1 alpha of pi, and alpha and beta of course belonging to the same interval, semi-open right semi-open between 1 alpha of negative 1 alpha of pi and 0. Of course, x is negative, x and y are both negative. We have from this inequality pi minus beta not greater than alpha less than minus 1 alpha of pi minus beta, which becomes dividing in two parts this inequality, the relation named called 2 minus pi minus beta is not greater than alpha not greater than 1 alpha negative 1 alpha of pi, or negative 1 alpha of pi less than alpha less than negative 1 alpha of pi minus beta. Using the second part of the relation 2 and taking into account the decreasing ratio of the sign in considered interval, we have sine alpha greater than sine of negative pi minus beta. So we have the first part sine alpha not not less than sine beta. So x not less than y. If you change the role of alpha and beta, you'll find y not less than x. The relation between x and y and is symmetric. I won't say it anymore. Okay. In considering the other part of the relation, we have sine alpha less than sine minus 1 alpha of pi minus beta, and so we have sine alpha less than negative sine of beta plus pi Greek, 1 alpha of pi Greek. So we have sine alpha less than minus cos beta, and taking into account the sign of sine alpha and minus cos beta, we have sine alpha square, sine square alpha greater than cos square beta. So sine alpha, sine square alpha greater than 1 minus sine square beta, and we have finally x square plus y square greater than 1. Okay, the relation triple I can be rewritten in this way: arcsin x plus arcsin y equal s minus p minus arcsin of x times square root of 1 my y square plus y times square root of 1 minus x square, and minus 1 is not greater than x and y, both negative, and we have x square plus y square greater than 1. So the remaining relation, the so-called y, by complementarity can be written in this way: arcsin x plus arcsin y equal the same expression, and minus 1, or to better say x and y between minus 1 and 1, with x square plus y square not greater than 1, or x and y, x times y negative, and x square plus y square greater than 1. Okay. Taking into account arcsin x minus arcsin y equal arcsin x equals arcsin x plus arcsin of minus y, and considering the symmetry of the interval of the definition of arcsin, we can easily rewritten the formulas of subtraction for arcsin in the following three way, and with the relation underwritten to the equality. Okay, you can take note easily until I pass to formula relative to arcsin. Oh my God. Okay. we start examining the obvious equality arccos x plus arccos y equals to arccos of cos arccos x plus arccos y, using the addition formulas for cosine. We obtain arccos xy minus square root of 1 minus x squared times square root of 1 minus y squared. Okay, actually, in the same ways as arcsin, this equality is valid only in a first approximation, and we should modify this equation in consequence of the position in the unit circle of the sum arccos x plus arccos y. So we have three kind of equality. The first one y, the second one double I, not y, I, and two kinds, sorry, I got confused. Okay, I and double I. Okay, arccos plus arccos x plus arccos y equals arccos x times y minus etc. and arccos plus arccos between 0 and pi Greek, or arccos plus arccos x plus arccos equals to 2 pi minus the same expression above mentioned, and arccos x plus arccos y strictly between pi and 2 pi. Okay, in same way, set arccos x equal alpha, arccos y equal beta. So we have x equals cos alpha and y equals cos beta, and alpha and beta are both in the closed interval 0 pi Greek. Okay, and naturally, evidently, we are interested in a formula related to x and y, like in the previous case. Okay, we start considering the double I situation. We have pi Greek less than alpha plus beta minus less than 2 pi. So we have pi minus beta less than alpha less than 2 pi minus alpha. Okay, I can split in two parts this the last this inequation in two parts. I've called three relations: pi minus beta less than alpha minus not greater than pi, or pi not greater than alpha less than 2 pi minus beta. Okay, if we consider the first part of three, we have considering the decreasing ratio of cosine, we have cosine alpha less than cosine pi minus beta, and we have cosine alpha less than minus cos beta, and x less than negative y, sorry, and so finally we have x plus y less than 0, x plus y negative. The other part of the relation, from the other part of relation, we can infer that x minus not greater than y and changing the role of alpha and beta, we have the symmetric relation. It is not important for our considerations. Okay, so we have arccos, the y becomes arccos x plus arccos y equals 2 pi Greek minus arccos x times y minus square root of 1 minus x square times square root of 1 minus y square, with x plus y negative and x and y between negative 1 and 1. The second relation can be obtained by complementarity. So we have arccos x plus arccos y equals arccos xy minus square root of 1 minus x square times square root 1 of 1 minus y square, with x plus y not negative and minus 1 not greater than x and y, not greater than 1. Okay, we can examine arccos x minus arccos y. We have in the same way of the previous reasoning, the two formula, arccos x minus arccos y equals arccos etc, etc, and so on. We can take note easily of this formula if we want, of course. Okay, a little problem on the sequence of imagination. Okay, I hope it is possible to say to say it in English in the order of the page. Okay, we can consider now the formula, the addition formula for arctangent. Okay, we have the obvious relation, which is arctangent x plus arctangent y equal arctangent of tangent arctangent x plus arctangent y. I use the Latin way of denoting arctangent with arctg. I'm sorry, but I too confident with this notation. Okay, arctangent x plus arctangent y finally equals arctangent x plus y over 1 minus xy because of the addition formula for tangent. We have arctangent of x and arctangent of y belonging to open interval minus 1/2 of pi. I'm very sorry. I apologize for this mistake, horrible mistake. Okay, arctangent of x belonging to minus 1/2 of pi, 1/2 of pi. So arctangent of y does. Arctangent x plus arctangent y actually is divided in three equality because we should take into account the place of the unit circle, the quarters more precisely, of the unit circle where arctangent of x plus arctangent of y is situated. Okay, so we have three kind of equation called y double y, I double I and triple I. We set arctangent x equals alpha, arctangent y equals beta, so we have easily x equals tangent alpha and y equal tangent beta. Of course, for the third time, we are interested in formula related to x and y, so we should modify the y, I, double I and triple I. We start from triple I. We have pi Greek less than alpha plus beta less than pi Greek, with alpha and beta belonging to the open interval between 0 and 1 alpha of pi. We can modify this relation into 1 alpha of pi minus beta less than alpha less than pi minus beta. So p minus beta is greater than pi minus pi 1 alpha of pi equals 1 alpha of pi. We can constrain alpha between strictly between pi 1 alpha of pi minus beta and pi and 1 alpha of pi, sorry, by the decreasing ratio of tangent. We have tangent of 1 alpha of pi minus beta less than tangent alpha, so we have cotangent beta minus tangent beta, and taking into account the sign of the positive sign of cotangent beta, we have tangent alpha times tangent beta greater than 1. So we have x and y positive, both x and y positive, and xy greater than 1. Okay, we have a little problem with the order of the pages. Okay, so we can rewrite the triple I, arctangent x plus arctangent y equal arctangent x plus y over 1 minus xy minus pi Greek, with xy greater than 1 and x positive. Of course, epsilon 2 is positive. Considering the double I equation, we have alpha plus beta belonging to minus pi Greek minus 1 alpha of pi, and alpha and beta belonging to the same interval, open interval, minus 1 alpha of pi and 0. We have minus pi less than alpha plus beta minus 1 alpha of pi. Since beta is less than negative 1 alpha of pi, we have minus beta less than 1 alpha of pi. We have moreover we have cotangent beta negative, so for the relation minus beta less than pi, we have minus negative pi minus beta less than alpha less than minus 1 alpha of pi minus beta. So we have minus pi minus beta less than alpha less than 1 alpha of pi, and considering that minus beta is less than pi 1 alpha of pi, we can strictly constrain alpha between negative 1/2 of pi, alpha and negative 1/2 of pi minus beta, and taking into account the increasing ratio of the tangent, we have tangent alpha less than tangent minus 1/2 of pi minus beta, which becomes tangent alpha less than cotangent beta. Cotangent beta is negative, so we have tangent alpha times tangent beta greater than 1. So we have x and y negative, and x times y greater than 1. So the relation double I can be rewritten in this following form: arctangent x plus arctangent y equals pi plus arctangent of x plus y over 1 minus x times y. Well, so by complementarity, arcotangent x plus arctangent y equals arctangent x plus y over 1 minus xy when xy is less than 1. Using the formula arctangent x minus arctangent y equal arctangent x equals arctangent x plus arctangent minus y, and considering that the interval of the definition of the tangent of the arctangent is symmetric, we can obtain substituting minus negative y with y in the previous formulas. We find arctangent x minus arctangent y equals arctangent x minus y over 1 x plus y when x times y is less than negative minus 1, and so on, as you can see, as you can look at it. Thank you. I apologize for my English, but I am sure that your Italian is much worse than my English. Ha ha ha! I'm joking, of course. Bye bye for now.